Section 4.3 problems. First one asks us to use the power rule to expand the common log of 100x. Okay, let's do that. So the common log of 100x, 100, that is your m, the x, that is your n, and you have multiply in between, so we use the product rule. So this will expand to be the log of 100 plus the log of x. But the log of 100 means the base 10 to what power equals the number that you take the logarithm of. And so that exponent there would be 2. So log of 100 is 2. So 2 plus log of x would be our final answer. Let's add to that new. Let's do problem 1b. So this is a new one that I'm making up right now. Let's take log base 2 of 8xy. The reason why I make this example is that we have a triple product here. Does the product rule still apply? Yes, it does. This will expand, here you have m, here you have n, and here you have r, and they're multiplied together. So that expands to be the sum of the logarithms of each piece. Log base 2 of 8 plus log base 2 of x plus log base 2 of y. Now look to see if there's any further simplification. Log base 2 of 8 means 2 to what power is equal to 8. In this case, we know the answer is exactly 3. See, if this were 2 to the x equals 7, then we couldn't simplify this so easily. We could approximate it using the calculator. But here, it's an integer value. 2 to the third power is 8. 2 to the third power is 8. So this is the number 3. So our final answer is 3 plus log base 2 of x plus log base 2 of y. And that's our final answer for our new problem 1b. Let's take a look at problem 2. Use the quotient rule to expand that quantity. Okay, this one we did in the PowerPoint slide, so let's take a look at a new problem 2. Let's try natural log of x squared plus 3 divided by x plus 1. Okay. What point am I trying to make here in this new problem 2? Well, we still have the log of m over n. The m is rather large and the n is rather large, but m and n do not need to be a single variable or a single number. So this still expands by using the product rule. This is the logarithm of the numerator, x squared plus 3, minus the logarithm of the denominator, x plus 1. Now, as I mentioned in the PowerPoint slide, never, ever, ever distribute here. That is invalid math. So this cannot be simplified. No further simplification. Now here, well, we have the same thing. We have the log of a sum. So what applies here is also applying here. Yes, we have a power. Cannot we put the power in front? No, we cannot. The logarithm of x squared is 2 natural log of x. Yes, but the logarithm of the sum x squared plus 3 is not twice the log of x plus 3. Cannot do that because we have a sum right here. So no further simplification can be done, and that is our final answer. And that's part of the point of bringing that problem in there. So this we'll call new problem 2a. Let's take a look at a new problem 2b and do a variation here. How about the natural log of the square root of e all divided by 3? That is still the log of m divided by n. So we will still use the quotient property, the log of the numerator minus the log of the denominator. Now, the numerator, square root of e, can be written as e to the power 1/2. 1/2 exponent means square root. And then if you wish, you could either use the power property, which puts the 1/2 here in front, or you can use the inverse property, natural log of e to the x is just x. Either way, you get 1/2 resulting from the first piece minus the natural log of 3 from the second piece. So we have that. And I think I'm going to squeeze in one more 2c just to show you something slightly different. Suppose you want the logarithm, let's do common log. Let's do logarithm of common log, 0.01. Now it's true you could appeal to the calculator since this is common log. Base 10 logarithm is done on the calculator. But why is the number that results on the calculator the answer to the problem? How do you show that in the mathematics? And that's the point of making this new problem 2c. So let's think about it this way. This is 10th hundredth, this is 1/100th. So write it as a fraction. 0.01 is 1/100th. There we go. Now we have it written as the log of m divided by n. So let's simplify that using the quotient property. That's the log of the top minus the log of the bottom. Okay. Now the log of 1, by properties of logarithms, is 0. 10 to what power yields 1? 0. And log base 10 of 100, we had earlier in the PowerPoint slide, 10 to what power is 100 is 2. And 0 minus 2 is -2. So this right here is the number -2 written in logarithmic form. Let's take a look at what we have next. Problem 3, use the power property to expand. Okay, this one we did in the PowerPoint slide. So let's do a new problem 3a, and we'll try log, let's put it base 3 of the number 1.37 to the power x. Okay. Well, we still have log base b, m to the p. And the power property allows us to put the p in front as the multiplier times log base 3 of the number, 1.37. And yes, it's true on the calculator. If you wish, you could compute this quantity here and estimate that on the calculator, and then you'd have a number times x. And that would be a different way to represent your answer. Let's do a 3b. Let's take a natural log, and let's do e to the power 0.035x. The other reason why I'm doing these two examples here is that this will work its way into what is yet to come when we solve equations. So yes, it's natural log, and yes, we have e, and looks like everything changes, but this is log base b. The b happens to be the natural exponential number e. Log base b of m to the p. So once again, the power property applies. Bring the entire exponent down in front, 0.035x, times the natural log of the number. Now, natural log of e is 1, so this is just the number 0.035x, because this part right here is 1. Okay. Let's take a look at what we have for problem number 4. Problem 4, use the power property to expand that quantity. We did that one in the PowerPoint slide. So let's do a new problem 4. Let's modify it just a little bit. So we'll take a new problem 4 to be expanding the log of, let's make it a product of two things. And let's put a power on there too. Let's make this a little challenging. Well, that's a big expression. So first take a look at what you have. This right here is m. This entire thing right here, that's n. And we have multiply in between, so we have log of a product. Therefore, the power rule applies. So this is equal to the log of the first piece plus the log of the second piece, x plus 3 to the power 5. Okay. Now, can we do anything with that? Well, not with log base 10 of x. That stays the same. But here we have the log of m. All of this is your m to the p. P is 5. So this could be rewritten to be 5 times the log of x plus 3. No further simplification is possible. Remember that any attempt at distribution is never correct. So there's a new problem 4. Let's see what we have for problem number 5. Use logarithms to expand the natural log of the cube root of x. Okay, this one's new, so let's do this one. The natural log of the cube root of x. Okay, now cube root of x means x to the power 1/3. Square root means power 1/2. Fourth root means power 1/4, and so on. Now we have the log of m to the p, so we can apply the power rule 1/3 times the log of x. And that one's done. Let's take a look at the next one. Use log properties to expand that expression. Log base b, so it's a generic base, x to the 4th times the cube root of y. Okay, so let's see. Log base b of x to the 4th times the cube root of y. Okay, well, I'll make one small change first. We know from the previous problem that we can rewrite the cube root as the power 1/3. Now, only the y is being cube rooted, so only the y has power 1/3. Now we have log of m times the log of n. So we use that property next. So this is the log base b of x to the 4th plus log to the same base b of y to the 1/3. And then finally, now that we have it pulled apart in individual pieces, we can apply the power rule, and the power becomes the multiplier. So 4 times log base b of x plus 1/3 log base b of y. And that is our final answer. Okay, let's see what else we got. Problem number 7. Use logarithms to expand log base 5, so let's write it here, log base 5 of the square root of x, all divided by 25 y to the power 3. Okay, so although that's rather a lot of things right there, this is still m divided by n. And m and n can be of any size. It's the fact that we have a quotient. Okay, so I will first rewrite square root is 1/2 power. And then that's an easy step to make. Gets me one line on the paper. And then from there, I'll use the quotient property. So this is log base 3 of x to the 1/2 minus log base 3 of 25y to the 3rd. Gets me that far. Okay. Now, I can use the power property here if I wish, log base b of m to the p, so I could write 1/2 log base 3 of x. But I cannot use the power property here because we still have a product. The product must be expanded. You have to be careful because you have a minus sign out in front, and this is going to be expanded into two pieces. So minus parenthesis log base 3 of the first piece plus log base 3 of the second piece. Okay, it's important to have the parenthesis in place there. So I'll do two more things. This power now can come in front, and this minus sign can distribute to each term. So by doing that, we have 1/2 log base 3 of x minus log base 3 of 25 minus 3, using the power property there, log base 3 of y. And I take a quick final look to see if there's anything more I can simplify. 3 to what power is 25? Don't know. 3 to the 3rd power is 27, but I don't know how to get 25. So you could get this on the calculator if you wish. This is your exact answer right there. Let's see what else we got here. Problem number 8. Write as a single logarithm. So we've got common log of 25 added to the common log of 4. Common log of 25 added to the common log of 4. Okay, well this is a version of log m plus log n, which by the property gives us the log of the product m times n. So this is condensing. That's why it says write as a single logarithm. So this is the logarithm of 25 times 4, which is the logarithm of 100. Because it's base 10, 10 to what power is 100? 2. So this is the number 2 written in log form. It's kind of like it's written in secret code. Why write a 2 if you can write that in its place? Let's take a look at problem number 9. Problem 9. Write as a single logarithm. So we have 2 natural log of x added to 1/3 natural log x plus 5. 1/3 natural log of x plus 5. Okay, we have to get this to a single logarithm. First, you have to take care of the multipliers. They become the powers. So this will be the natural log of x squared plus the natural log of all of this, and now the exponent is now 1/3. Okay. Now, exponent of 1/3 means cube root. So I can rewrite this as the logarithm of the cube root of x plus 5. So that's just using a rule of exponents to rewrite that expression. Now I have log of m plus log of n, and we can rewrite that as the log of m times n times cube root x plus 5. And there we have it written as a single logarithm. Let's take a look at problem 10. Write as a single logarithm. Okay, so now looks like we got 3 pieces to manipulate. So let's record those pieces right here. 1/4 log base b of x, 1/4 log base b of x, and then we have minus 2 log base b of 5, and then minus 10 log base b of y, minus 10 log base b of y. Okay, this one's a little tricky. As before, we can take care of the multipliers and make them exponents. So we can say that this is equivalent to log base b of x to the 1/4 minus log base b of 5 to the power 2, and then minus log base b of y to the 10th. And we might as well do some easy simplification while we can, before we use more properties. 1/4 power means 4th root. Okay, and of course 5 squared is 25, so let's just put a 25 there in its place. And we'll just copy this one down, log base b y to the 10. Okay, now I see a minus sign here and a minus sign here. What I'm going to do is factor out the minus sign. And the reason why I'm going to do that is it makes the math a lot easier if you factor it out. So pull out the minus sign. Now what's left? You have log base b of 25 plus, right? Negative times this quantity is negative. Negative times plus is negative. Log base b of y to the 10. Now that you've done that, we have a sum right there. So we can write that as the log of the product. So this is log base b 4th root x minus. This condenses to one single expression. Log base b of 25y to the power 10. Log of m plus log of n is log of m times n, like that. Now I see a minus sign there. Log of m minus log of n. So this now can be rewritten as the quotient. So this is log base b of 4th root of x, all divided by 25 y to the 10, like that. And now we have it finally condensed all the way to a single logarithm. Let's take a look at the next problem, number 11. Okay, 11 and 12 we did on the PowerPoint slide, so let's do a new 11 and 12. So new 11 will be, right, hey, how about log base pi of e? Write that using common logarithms. So we'll still do the common logarithms, but for this one, pi's, e's, 2, irrational numbers, it does not make a difference. We still use the very same change of base formula. We want to change to common log. So it's going to be common log in the top and common log in the bottom. In the numerator is the log of, this is the m, so it's common log of m divided by the common log of the base. There we go. And that is done. And this one you can do in the calculator, and this one perhaps not. So problem 12 asks us to convert to natural logarithms. So let's take the same one. This is 12. Let's take the same one, log base pi of e, and let's rewrite that using natural logarithm. Okay, so we'll have a natural log on the top and the bottom, and the same rule. So it's the log of m divided by the log of b. There you go. Now in this case, the natural log of e happens to be 1, so we could do one more line of simplification. 1 over the natural log of pi. And that's the conclusion of section 4.3 problems.